Now that we've seen both the calculation of simple linear regression and the Excel add-in for simple linear regression, we're going to look at regression as a t-test. The data we're using is data relative to an experimental and a control group of women in an educational program for breast cancer. The experimental group is shown as (25) women, and the control group is shown as an additional 15 women. The data are set up as they would be for carrying out a t-test. We're going to rearrange the data to set it up as it would be if we were going to use regression as the t-test. First thing we'll do is add a column here where the control is, and we'll put in a 0 for each one of the controls, going all the way down to the bottom of the control group. And we'll add a column here and put in a 1 for each of the members of the experimental group, going all the way down to the bottom of the experimental group. Now we're going to take the control group, highlight the entire control group, and going back to the top, we're going to take the control group and move it. Now I've moved it clear out of sight. I'm going to move it to the right, and I have added it beneath the experimental group. Now the labels are no longer relevant. I'm going to cut those. Actually, I'm going to clear those. And instead, I'm going to put in score and experimental / control. So now in the variable marked experimental control, a woman is assigned a 1 if she was in the experimental group, or a 0 if she was in the control group. And score is simply the score that the women received on the training program. So now I'll go to Tools, Data Analysis. I'll go to Regression. When I say OK, it asks for a Y input range, and I will select the score, and I'll do a Control-Shift down arrow, and that actually goes all the way to the bottom of the data. And now I'll select the X input range, Control-Shift down arrow, and the same thing happens. There are labels in the top row. The output range this time is going to be D2, and when I say OK, this is the result that I get. So what do I have here? First of all, this R-square says that knowing whether a woman is in the experimental or the control group accounts for 14, almost 15% of the variance in her score. The F-test says that this is a statistically significant result. That is, that this coefficient on experimental control of 2.5 is different from 0. And this t-test with a probability of 0.001 says the same thing. So even though 15% is relatively small, we're actually accounting for some of the variance between the experimental and the control group. Now in this context, what does the intercept and what does the coefficient on the experimental control group mean? Let's go back to the data and look at the average for the experimental group. Right here I'm going to type equal average, and I'm going to select just the experimental group, and if you see where I have gone with this, I've selected those people with 1s in their experimental control variable. When I hit enter, I find that the average is 10.04. At this point that doesn't mean much, but let's look at the average for the control group. I'll go down, find the first member of the control group, and move the average line down to the bottom of the entire data set. So now I've highlighted just the control group, and when I hit enter, I get 7.525. But that 7.525 is exactly the same as the intercept. So when I have a dummy variable, that is a 1-0 variable, as the predictor, the intercept will always be the mean of the group assigned 0. Now what is the 10.04? Well, if I look at the 7.25 and the 2.51 and add those together, 7.5 plus the 2.5, I get 10.04. So the mean for the group that is assigned 1 on the experimental control variable is the intercept plus the coefficient for the variable. The t-test is exactly the same result as a t-test assuming equal variance, and the probability of the t is always a two-tailed probability in the regression analysis.